Hey there everyone, welcome to another Calculus 1 video. We are going to cover sections 3, 9, and 10 today from our textbook, but it's only going to be the rules. So section 3.9, there's only one rule, and then section 3.10, we're going to focus on 3 of the 6 given rules. We are not going to do anything with logarithmic differentiation or any of that other stuff in 3.9. So that's why I combine these two sections. 3.9, we're talking about the natural logarithm. Remember what the natural logarithm function means? It means that x is equal to e to the y power, because ln is log base e, where e is the natural exponential function. So if we want to find dy dx for this guy right here, that means that we could find dy dx over here instead, because it's the same equation. It's just written in a different form. And I can do this. I already have a rule for e, and I can do this implicitly. And so I'm going to take the derivative implicitly of x equal e to the y. The derivative of x is 1. The derivative of e to the y is e to the y times dy dx. And so if I solve for dy dx, that means divide both sides by e to the y. And so what do I get? I get that 1 over e to the y equals dy dx. And so if y is equal to the natural log of x, apparently that means that the derivative is supposed to be 1 over e to the y. But wait a minute, what is e to the y? E to the y is x, based on this definition. So I actually get my derivative for the natural log function to just be 1 over x. And so that's the rule that we're going to utilize, that the derivative with respect to x of the natural log of x is equal to 1 over x. That's our rule. Add that to your list with your sine and cosine and e to the x and all that kind of stuff. And so how does this look? Here's a couple of examples. If y equals x cubed times the natural log of x, then what's the big picture here? The big picture is a product. And so we take the product rule and we get the derivative of the first times the second plus the first times the derivative of the second, just as we've always done in this chapter. I'm not going to ask you to simplify that any at all. And so this is perfectly fine. All right, that's great. But now what happens if we need to take the derivative of a natural log function that has a natural log of some stuff? What happens now? Well, this is what? This is like a u. U is x squared plus 4x plus 5, and y is natural log of u. And so it's a chain rule. It's a composition of functions. So the derivative, what's the derivative of the natural log of u? 1 over u. So the derivative of natural log of stuff is 1 over the stuff. X squared plus 4x plus 5. And then, of course, we multiply by the derivative, du, of the stuff, and that stuff is 2x plus 4. You may leave it like this, and certainly you can combine these two and put 2x plus 4 on the top and x squared plus 4x plus 5 on the bottom. But again, the idea is this, is that if y equals natural log of u, then dy du is 1 over u. And so to get dy dx, we have to take dy du times du dx, and it's multiplying by the stuff inside. Okay, so chain rule, just like normal chain rule. I want you guys to try one. I want you to do this one. Let y equal 5 natural log of the sine of x. I want you to find dy dx, or y prime, or whatever. We're not doing implicit differentiation. We used implicit differentiation to derive the natural log derivative, but this is not implicit differentiation, okay? So don't let the notation fool you. Pause the video and see what you can get. Okay, so dy dx The 5 just comes along. And then this big picture here is the derivative of the natural log of stuff. So once again, we get 1 over the stuff, 1 over sine of x, times the derivative of sine, which is cosine. And so again, I'd be fine if you left it that way. To be fair, if we simplified this, cosine over sine is cotangent, so it actually simplifies significantly to 5 cotangent of x. Okay? And so that's the way you handle the natural logarithm. It's 1 over the stuff times the derivative of the stuff, or if it's just natural log of x, it's just 1 over x. Okay, there's plenty of practice problems for 3.9 in D2L. Now we head over to 310. 310 is the inverse trigonometric functions, and so I need to talk about these for just a little bit. First of all, these are the 6 rules. I told you I was only going to ask you for 3. These guys I don't want. I don't want you to worry about these guys, okay? But these domains still apply. So these domains apply for x between -1 and 1, that's this. For x, all x, that's the inverse tan. And for absolute value of x greater than 1, that's secant. But notationally, I don't like this. Okay, remember that sine inverse of x is the same thing, or another way to write that is arc sine. And while your textbook doesn't write it as arc, I will. I refuse to use inverse tangent or inverse sine, mainly because students struggle with thinking that's a power, and it's not a power. It's not a -1 power. That secant inverse of x is not 1 over secant. That's not the way it works, okay? So I will exclusively use arc sine, arc tangent, and arc secant for these, but you need to recognize it because, right, your math lab and other things like that will use those, okay? So let me show you how these work. Once again, these are just the rules, and so if you have these rules in tandem with other rules, you have to apply them in the proper format, okay? So as example, if you have f of x equal to the arctangent of x all over 3x squared plus 4x, okay, then when you go to take the derivative, you get the bottom times the derivative of the top. The derivative of arctangent's 1 over 1 plus x squared, that's the rule we just saw, minus the top times the derivative of the bottom, which is 6x plus 4. And then that's all over the bottom squared. Again, I am very well aware this is a complex fraction. That's not ideal, certainly not simplified, but I am still okay with it. Okay, I am still okay with that answer. So why don't you try one, but I'm going to just give you a hint, right? I'm going to let f of x equal, we're going to go arctangent again, arctangent of 3x squared plus 4x. So now we don't have, that's not a product. This was a quotient, but that's not a product, right? Here arctangent still had a x with it. Here arctangent doesn't have anything with it except for this, so that's not a product. This is arctangent of stuff. And so you've got to use the chain rule. All right, so pause it for a minute. You know the rule for arctangent. Go back here if you need to. That's the rule for arctangent. And then try this one. Pause the video, come back and see how you did. Okay, so the derivative, what's the big picture? It's arctangent of stuff. What's the rule for arctangent? It's 1 over 1 plus the stuff all squared. 1 over 1 plus x squared. If that's a u, that becomes 1 over 1 plus u squared. And so this is your u, and then you multiply by the derivative of the stuff inside, which is 6x plus 4. Again, you can leave it like this. You can take the 6x plus 4 up top, but there's no reason to. This is a perfectly good derivative. No need to simplify. Okay? So, what do you need to do? You need to do lots of practice. Again, this is a very simple section in which you just have some new rules to use and apply all of your other rules. Chain rule, product rule, quotient rule, and now you've got 4 new rules Okay, 4 new rules. Just a reminder, for those of you that need a little pre-calculus reminder, what does this mean? When I say y equals arc sine of x, or sine inverse, that means that x equals sine of y. So we can actually derive the formulas like I did the natural log formulas by implicitly differentiating this and solving for dy dx. But I'm not going to show you that right now. If you want to see it, I'll gladly show it to you. I'm sure you can Google it and find one. It's very similar to the process that we went through for logarithm. Finding it in terms of x is a little bit more challenging because you have to draw a triangle and get your signs lined up. But anyway, so if you have questions about that, I'm happy to answer them. But pretty much what I want you to do is I want you to know these 3 rules and the natural log rule, all right, and be able to apply those as needed. Okay? Practice, practice, practice. We'll see you later. Thanks.